All right, guys, your essential question is how do we apply the first derivative test to find relative extrema and intervals of increasing and decreasing behavior? Well, for this part of the lesson, we're going to focus on the first essential question, first derivative test to find relative extrema. So your vocabulary word, first derivative test, we're actually going to use for this lesson. Okay, let's do a little bit of, I guess you could say, review. Remember that if a function has a relative min or max at c, then c must be a critical number of the function. So in other words, if it's a relative min or max, if it's an extrema, then it's a critical number. The converse of that is not true. Not every critical number is a relative extrema, which you can look at a previous video and show that that is true. So, a new calculus method is needed to determine whether relative extrema exist at a critical point and if it is a maximum or minimum. So now I'm going to teach you not only how to get a critical point, but how do we use those critical numbers to determine if it's a relative max or a relative min. Now, just because it's a critical number doesn't mean it's going to be a max or a min. So there has to be a rule to tell when it's a max or a min, and that's what we're going to go over. Okay, how's the derivative connected to relative maxes and mins? Well, when a critical point is a relative maximum, so for example, notice that B, this is a relative maximum. What are the characteristics of the function? What I want you to look at is look at the value of the derivative of this function. If you notice, the function is increasing here. So that means the derivative is positive, right? Because wherever the graph is increasing, the derivative is positive. Now, after it hits that max, what's the graph doing? The graph is decreasing. Now, when the graph is decreasing, what does that mean about the derivative? That means the derivative is negative. Notice that there is a sign change. So if you notice, the derivative is positive, it reaches the max, and now the derivative is negative. So that's a tail giveaway that whenever you have a sign change from going positive to negative, you're going to reach a max. Now, look at the minimum. Point C is a minimum value, right? So look at the characteristics of the function now. Well, the function was decreasing, so the derivative was negative, but after C, the derivative, the function is increasing, so that means the derivative is positive. So a tail giveaway that it's a relative min is if the derivative is negative and then it's a critical number and then the derivative is positive, then that's a tail giveaway that the critical number is a min. So what you have to look for are sign changes. Now, if there is no sign change, for example, if you hit a critical number, it's positive on the left, positive on the right, or if it's negative on the left, in other words, if there's no sign change, that means it's not a min or max. So just to recap, so you can see pictures, if you have a critical number, if the derivative is positive on the left and then negative on the right, then you have a relative maximum. Okay? If you have a critical number, and the derivative on the left is negative, and the derivative on the right is positive, then that means you have a relative minimum. Okay? And then finally, if you have a critical number and there is no sign change, so it's positive on the left and positive on the right for the derivative, and it's negative on the left and negative on the right for the derivative, then that means that it is not a max or a min, and there's actually another term for that, but we're going to cover that in a future lesson. All right?